Hydrocarbon compounds. It's a specific arrangement of atoms in an organic compound that is capable of characteristic chemical reactions. In a carbon chain, one or more hydrogens are substituted by a functional group changing its properties. These are some examples of functional groups. Halocarbon. It's a compound containing a carbon chain with a halogen substituent. Halocarbon compounds are chemicals in which one or more carbon atoms are linked to one or more halogens atoms. Examples are fluorine, chlorine, bromine, or iodine. The best known in this group of gases are the chlorofluorocarbons, the hydrochlorofluorocarbons, and the newer substituents hydrofluorocarbons. While the concentration of halocarbons are much lower than those of other greenhouse gases, the warming effect that they produce ranges from 3,000 to 13,000 times that of carbon dioxide. If the halogen substituent bonds to an aliphatic chain, it is called alkyl halide. Here we have three halocarbons. The first, as you can see, there is only one carbon, so the name will be trichloromethane. The second one is back again, only one carbon, but four chlorines, so they will be tetrachloromethane. And then the last one we have chloro and fluoro, so that will be 1,2 dichloro, 1,2,2 tetrafluoroethane. If the halogen substituent bonds to an arene ring, it is called aryl halide. In here we have three examples. The first one is the benzene with a chloro on top, and that will be chlorobenzene. The next one with iodobenzene, and then the last one we have two bromines, so that will be 1,4 dibromobenzene. Alcohols. An alcohol is an aromatic compound with at least one hydroxyl group, OH, attached to it. What's common among these products? Well, all these products have alcohol. Alcohols are classified according to the number of carbon groups, or R groups, attached to the carbon with a hydroxyl group. In here we can see one carbon attached to the hydroxyl, and that is called primary. If the carbon attached to the hydroxyl group is bonded to two carbons, that will be secondary. And the tertiary will be when it's three carbons attached to that carbon. When naming alcohols using UPAC system, change the E ending of the alkane and add OL. From the rest of the functional groups, continue as normal naming. An alcohol is an aromatic compound, organic compound, with at least one hydroxyl group. Remember this. Okay, so in the first example, we can see we have only one carbon and an OH. That will be, instead of methane, that will be methanol. The second example, we have two carbons, so instead of ethane, that will be ethanol. The third one had three carbons, that will be, instead of propane, 2-propanol or just propanol. And then the last one we have the OH, but also we have a methyl group on it with three carbons, so instead of propane, that will be 2-methyl 2-propanol. When the hydroxyl group is attached to an aromatic compound, the result molecule is called a phenol, and they are used to make plastics, fibers, and drugs. Here is the phenol. Now, if we have, for example, a group attached to it, we will just normally go naming, and that will be 2-methylphenol. General properties and uses of alcohols. Okay, as we decrease the size of the molecular weight of the alcohol, it will increase the solubility and water sensitivity. Whereas, in the other hand, if we increase the chain size, it will increase the viscosity, the water resistance, and it will also increase the solvent resistance. Ethers. An ether is an organic compound in which oxygen is bonded to two carbon groups represented with the general formula R1OR2. Well, do you remember alkyl groups? Which were the alkyl groups for 1, 2, or 3 carbons? For 1 is methyl, 2 is ethyl, and for 3 propyl. In ethers, these groups will bond to an oxygen turning to the next. That will be methoxy, ethoxy, and propoxy. And they can bond in different carbons in a carbon chain, so a number will be required to indicate its position in it. Examples. Okay, the example in the left, as we can see, is 2-methoxyhexane because it's bonded in carbon number 2. Now let's take a look at the one on the right. We have a double bond, we have a bromine, and we have the ethoxy. So the name will be 3-bromo, 4-ethoxy, 1-hexene. Now let's try in these 4 structures. The first one, as you can see, we have methoxy that is bonded to an ethane chain, so that will be methoxyethane. The second one is methoxymethane. Next one, ethoxyethane, and the last one, diphenyl ether or phenoxybenzene. Properties. Ether molecules cannot engage in hydrogen bonding with each other. Ethers do have non-bonding electron pairs on their oxygen atoms. However, and they can form hydrogen bonds with other molecules, alcohols, amides, etc. They have the OH and the NH bonds too. The ability to form hydrogen bonds with other compounds makes ethers particularly good solvents for a wide variety of organic compounds and a surprising large number of inorganic compounds. Because ether molecules cannot engage in hydrogen bonding with each other, they have much lower boiling points than do alcohols with similar molecular weights. Carbonyl. A carbonyl group is in which oxygen double bonds to a carbon, allowing to form different molecule structures. In here we have the aldehydes and the ketones. If you check, the aldehyde is the carbon double bonded to oxygen, and it will have one hydrogen, and in the other side, the rest of the chain. The ketones, in the other hand, is a carbon chain, and one of the carbons will be double bonded to the oxygen. For both groups, find the longest chain that contains the carbonyl group. In aldehydes, substitute the E from the alkane to al. So for example, the first one will be benzanol. The other example will be methanol. Now, for ketones, instead of E, we will substitute by on. And in here we have 2 examples, that is propanone and butanone. Now, usually we have to number where this double bond with oxygen is located. In these 2 examples, it doesn't appear because it's exactly the same no matter where we begin. Here we have 3 examples. The first one, as you can see, is carbon double bonded with O and H, so that will be an aldehyde with 2 carbons, that will be ethanol. The next one is a carbon chain, only has the double bond with oxygen in carbon number 3, so that will be 3-hexanone. And the last one back again is an aldehyde with 3 carbons, that is propanol. Let's check on properties. Both aldehydes and ketones contain a carbonyl group. That means that their reactions are very similar in this respect. Boiling points increase as the number of carbon atoms in the chain increases. Van der Waals forces get stronger as the molecule gets longer and have more electrons. Aldehydes and ketones don't have any hydrogen atoms attached directly to the oxygen, and so they can't hydrogen bond with each other. Small aldehydes and ketones are freely soluble in water, but solubility falls with longer chains. Carboxylic acid and esters. Carboxylic compound is in which oxygen double bonds to a carbon, which in turn is bonded to a hydroxyl group and a carbon chain. Here you can see the carboxylic acid with the carbonyl group, double bond O, and the hydroxyl group, OH. And a similar compound is the ester, but in this time we have the double bond O, and instead of the hydroxyl group we have an oxygen bonded to an alkyl group. Now, for naming carboxyl groups, find the longest chain that contains the carboxyl group and substitute the E for the alkane with oic acid. For example, with 2 carbons, that will be ethanoic acid. For esters, it's a little bit different. Find the chain that bonds to the oxygen, and that will be the alkyl group with single bond. This is the alkyl group, remember. Then from the other chain, substitute the E by noate. So in our example, if you can see CH2, CH2, CH3, that will be propyl. So that will be propyl, and in the other side we have 2 carbons, so that will be ethanoate. Let's name these 3 structures. The first one we can see is a methyl butanoate. The next one we can see that it's a carboxylic acid because of the double bond OOH with 3 carbons, that will be propanoic acid. And then the last one is also a carboxylic acid, but this time with a methyl group in carbon number 2, so that will be 2-methyl butanoic acid. Carboxylic acid and esters are colorless. Boiling points increase as the number of carbon atoms in the chain increases. And back again, van der Waals dispersion forces get stronger as the molecules get longer and have more electrons. Esters can be obtained by the combination of the carboxylic acid and an alcohol, and this is called esterification. Esters are responsible of the most pleasant odors in fruits and flowers. Thank you for watching.